For most of human history, the night sky has been a place of comfort and wonder. People looked up and saw patterns in the stars, guiding their travels, inspiring their myths, and giving them a sense that the universe, while vast, was stable and eternal. But every once in a while, something appears in that sky that doesn't fit, something so unexpected that it rattles our sense of safety. Right now, that moment is unfolding before our eyes. Two massive interstellar objects, completely unrelated, coming from opposite directions, are racing toward our sun at the exact same time. Scientists are calling them 3IATLAS and Swan R2, but those names don't capture the strangeness of what's happening. One of them glows an eerie green, as if lit from within, while the other is already so large and bright that it stretches across the heavens like a cosmic warning flare. For ordinary people, this might just sound like another rare but harmless event in astronomy. But for researchers, and for those who pay attention to the patterns of the universe, the question is unavoidable. Is this really just chance, or are we witnessing something else entirely? Think about it, space is nearly infinite, and the odds of two objects arriving here within just weeks of each other are astronomically low. Yet here we are, and as if that weren't enough, Earth is in the worst possible position to keep track of them. Our telescopes are blinded by the glare of the sun right when these objects get closest, leaving the most important part of their journeys hidden from view. Almost like someone or something doesn't want us watching. Scientists will tell you it's coincidence, nothing more. But deep down, even some of them admit that the timing feels too perfect, too orchestrated. What are these objects? Visitors, weapons, ancient messengers? Or are they simply a reminder that we know far less about the universe than we like to believe? One thing is certain, this is not just another night in the cosmos. This is something far more unsettling, and the story is only just beginning. The story of 3IATLAS and Swan R2 begins with what should have been an ordinary night of skywatching. Astronomers are used to finding faint smudges of light that barely move against the backdrop of stars. Most of them turn out to be asteroids or comets drifting within our solar system. But on July 1st, 2025, something unusual happened. A telescope scanning the sky picked up a small pixel of light creeping along at a speed and trajectory that didn't belong to anything local. At first glance, it looked unremarkable, just another icy body passing through. But the more they tracked it, the stranger it became. This faint traveler wasn't circling the sun like normal objects do. It was cutting straight through our solar system, coming from the deep void of interstellar space. They named it 3IATLAS, marking it as only the third confirmed interstellar object ever observed, after the infamous Oumuamua in 2017 and Borisov in 2019. Already this was a historic discovery, but Atlas had something else that set it apart. Its color. Through powerful spectrographs, scientists realized that it was glowing green, an eerie hue caused by diatomic carbon and cyanogen. While comets sometimes display green comas, the intensity here was shocking, almost unnatural. Even more unsettling was the discovery of nickel emission lines in its chemical makeup, without the usual presence of iron. In astronomy, where chemistry is supposed to follow universal rules, finding nickel without iron is like finding a shadow without a source of light. It doesn't make sense. And when things in science don't make sense, people start asking questions that push the limits of what we think we know. If that were the whole story, it would already be a fascinating chapter in astronomy. But less than 2 months later, on September 11th, another sky survey revealed something even more dramatic. This time, the object wasn't faint. It wasn't hiding in the noise of the universe. It was bright, so bright that even with simple binoculars, backyard observers could pick it out against the night sky. This second visitor was named Swan R2, and from the very start it demanded attention. Its coma stretched millions of kilometers, and its tail flared like a beacon across the heavens. If Atlas was subtle, Swan R2 was flamboyant, almost theatrical. Together, the two objects painted a picture that was too strange to ignore. One faint, mysterious glowing green, the other massive, visible, roaring into our solar system like it wanted to be noticed. The question practically wrote itself. What were the odds? Scientists have calculated that the arrival of a single interstellar object is already rare, a once-in-years or even once-in-decades event. For two to arrive not only in the same year, but within weeks of each other, from entirely different directions, seems almost impossible. Think of it this way. Imagine tossing darts randomly from across a football field and having two land within an inch of each other. That's the level of coincidence we're talking about here. Yet coincidence is the explanation most official voices offered. They assured the public that yes, it was unusual, but not impossible. They said space is vast, and every once in a while, the improbable does happen. But while the official explanations leaned toward comfort, the details refused to stay quiet. Because when you line up the discoveries side by side, the pattern begins to look less like random chance and more like a narrative unfolding in real time. Atlas was faint, almost as if it were testing our ability to notice. Swan R2 was unmistakable, almost as if it wanted to be seen. Atlas carried strange chemical fingerprints that challenged our understanding of cometary physics. Swan R2 behaved in ways that didn't match known models of brightening and fading. Both arrived just as Earth's view was about to be blocked by the glare of the sun, ensuring that the most critical part of their journey, their closest approach, would happen while we were blinded. Each fact on its own might be explainable, but together they paint a picture of timing, design, and precision. And that's why some astronomers began whispering privately what others only dared suggest in interviews. What if these objects aren't natural at all? It's not hard to see why such suspicions emerge. The history of interstellar object studies has been steeped in controversy ever since Oumuamua, the first interstellar visitor, flashed through our solar system. That object tumbled strangely, reflected light inconsistently, and accelerated in ways we still can't fully explain. Some scientists speculated it was a natural shard of rock. Others, including Harvard Avazadma Avi Loeb, argued that its odd behavior could be the result of alien technology, perhaps a probe or a fragment of a much larger craft. While the mainstream dismissed those theories as sensational, the debate never really died. And now, with Atlas and Swan R2 showing up back to back, the old questions roar back louder than ever. Are we watching a replay of Oumuamua, only this time doubled? Or are we seeing the next stage of a story that began years ago, now unfolding with even higher stakes? Observers on Earth weren't the only ones intrigued. As the news spread, amateur astronomers joined in, tracking the objects with smaller telescopes, posting their findings online, and stirring up theories ranging from scientific to downright wild. Some insisted the green glow of Atlas was a sign of artificial propulsion, like a controlled burn disguised as cometary chemistry. Others suggested Swan R2's dramatic brightening could be a beacon, signaling something or someone across the stars. The mainstream community pushed back, labeling such speculation as unfounded. Yet at the same time, none could deny the sheer weirdness of the situation. And when scientists start sentences with "we don't know why," the imagination fills in the gap. The reality is that space rarely delivers coincidences so dramatic. Even if both Atlas and Swan R2 are natural, their simultaneous arrival forces us to rethink what rare really means in astronomy. It also forces us to ask whether our models of interstellar visitors are flawed, or whether we're witnessing something that falls outside those models altogether. In either case, the feeling of unease lingers. Why now? Why together? And why under conditions that make them so difficult to study just when it matters most? For the casual stargazer, it's easy to enjoy the spectacle, one glowing green wanderer, one massive tail lighting up the sky. But for those who look deeper, Section 1 of this story isn't about beauty. It's about the strangeness of two cosmic strangers showing up at the same party, uninvited, and at the same time, if Earth were a house and the night sky a window, we'd have to admit that the knock on the glass feels deliberate. And whether it's a friendly knock or something else entirely, we simply don't know yet. The night sky has always been full of quiet surprises, but few discoveries have caused as much of a stir as the moments when astronomers first laid eyes on 3IATLAS and Swan R2. To appreciate the strangeness of what unfolded, you have to picture what it's like for scientists hunting for cosmic wanderers. Most of the time, they are staring at endless streams of data from automated sky surveys, programs that sweep the heavens for faint specks of light moving against the fixed backdrop of stars. It's tedious work, like looking for a single grain of sand drifting across an ocean of identical grains. Yet sometimes, a pixel flickers that doesn't behave like the rest, and that's when everything changes. On July 1, 2025, one of those tiny flickers caught the attention of a team using the Atlas telescope system in Hawaii. At first, it seemed like just another dim, icy fragment wandering on the outskirts of the solar system. But the more they tracked it, the less it fit the usual pattern. Its trajectory was too sharp, too linear. Instead of orbiting the sun like an asteroid or a regular comet, it was cutting through the solar system on a hyperbolic path. In other words, it wasn't from here, It was coming in from interstellar space. The realization sparked a wave of excitement and disbelief. After all, only 2 confirmed interstellar objects had ever been recorded before, Oumuamua in 2017 and Comet Borisov in 2019. To suddenly have another labeled 3IATLAS was already historic. But as soon as the first images were processed, another layer of mystery emerged. Atlas wasn't just faint, it was glowing with a strange green hue that suggested high levels of diatomic carbon and cyanogen. While comets sometimes display green, the intensity here was unsettling, as though the object carried an inner flame. More intriguingly, early spectroscopy hinted at the presence of nickel without the usual accompanying iron. For astronomers, this was like finding a recipe missing its main ingredient. Nickel and iron usually appear together, especially in objects forged in the violent furnaces of stars. But here was Atlas, flaunting the rules of chemistry as we know them. That was the moment the whispers began. This wasn't just a comet, this was something different. But before scientists could even begin to wrap their heads around Atlas, another shockwave rippled through the community. On September 11, 2025, the Swan survey team spotted something bright streaking across the night sky. This object, quickly dubbed Swan R2, was impossible to ignore. Unlike Atlas, which required sensitive instruments to detect, Swan R2 was immediately visible, even to small backyard telescopes and binoculars. Its coma, the glowing cloud surrounding its nucleus, was massive, stretching millions of kilometers into space. Its tail blazed dramatically, glowing like a torch across the stars. To those who witnessed it, the sight was breathtaking, almost theatrical, as though the cosmos had staged a performance. In the span of just 2 months, humanity had gone from barely spotting one faint interstellar traveler to watching another explode into the skies with brilliance. At first, Swan R2 was treated as a routine bright comet, albeit a spectacular one. But the details quickly piled up, pushing it into the same category of what is happening here as Atlas. For starters, Swan R2's rate of brightening defied expectations. Normally, comets grow brighter gradually as they approach the sun, their icy surfaces vaporizing into tails of gas and dust. Swan R2, however, brightened at a pace far beyond what models predicted, almost as if it had a power source of its own. Astronomers tracked its output, scratching their heads as its activity suggested a level of volatility that didn't quite add up. And then came the timing. Swan R2 had been discovered just 72 days after Atlas, both barreling into the solar system from completely different directions, both unrelated, both unmistakably interstellar. What were the odds that 2 such objects would arrive not just in the same century, not just in the same decade, but within weeks of each other? That question quickly spread from academic circles to public forums. Some argued that it was pure coincidence, the kind of statistical fluke that happens once in a cosmic blue moon. Others weren't so convinced. The idea that the universe, with all its billions of stars and trillions of planets, would send 2 unrelated visitors our way at the same time stretched probability to its breaking point. The timing felt almost choreographed, as though both objects were following some unseen schedule. And when coincidences start to look like patterns, the human mind begins to wonder if something deeper is at play. The discovery moments themselves reveal an even stranger truth about our place in the universe. We're catching these things late, often when they're already on our doorstep. Atlas was barely detected when it was already halfway into the inner solar system, its faint glow nearly invisible until the right telescope happened to glance its way. Swan R2, on the other hand, practically announced itself, so bright it seemed impossible to miss. The contrast between the two only heightened the sense that they were playing roles in a larger story. Atlas, the subtle scout, quiet and mysterious. Swan R2, the loud arrival, dazzling and impossible to ignore. And hanging over both discoveries was a question no one could answer. Why now? The more scientists studied the initial data, the more the discoveries felt unsettling. Atlas had a faint, almost testing quality to it, as though it were designed to challenge our ability to detect it at all. Swan R2 felt the opposite, as though it wanted every eye on Earth to look up and take notice. It's easy to dismiss such interpretations as imagination, but when science itself can't explain the chemical oddities of one or the rapid brightening of the other, speculation fills the gap. Were these just rare natural oddities, or did they represent something more deliberate, something with purpose? The timing of the discoveries also raised another point of unease. Both Atlas and Swan R2 were set to make their closest approaches during a window when Earth's telescopes would be least capable of observing them, hidden by the overwhelming glare of the sun. In other words, just when we most needed clear observations, we were effectively blinded. To some, this was nothing more than bad luck. To others, it felt almost like a trick, as if the universe or something within it was making sure the details remained hidden. And for every scientist insisting this was simply the way orbital mechanics worked, there were voices pointing out how conveniently inconvenient the timing was. So, the discovery of Atlas and Swan R2 wasn't just about adding 2 more names to the catalogue of cosmic wanderers. It was about the way they appeared, how they defied expectations, and how their timing created a puzzle too coincidental to ignore. One faint green chemically baffling object, one massive blazing unpredictable comet, both arriving back to back, both slipping into the sun's glare before their closest encounters. The discovery moments were not just moments of awe, they were moments of discomfort, leaving us with the feeling that we were catching only glimpses of a story that might be much larger than we could imagine. And as much as scientists tried to reassure the public that everything was explainable, the truth was that behind closed doors, many of them were asking the same unsettling question. What if it's not just coincidence? When scientists first turned their instruments on 3IATLAS, they expected to see the usual chemical fingerprints of a comet. Most comets, after all, are nothing more than dirty snowballs, ice mixed with dust, carbon compounds and metals forged in the hearts of long-dead stars. They light up as they approach the sun, releasing gases that scatter sunlight into shimmering comas and tails. But Atlas broke the script almost immediately. Its faint glow wasn't white or yellow, but an eerie green, a color linked to diatomic carbon and cyanogen. While both are known in cometary science, the intensity of Atlas's emissions seemed out of place. The green radiance was so sharp that it looked less like a natural outgassing and more like a neon sign in the void. The first question that popped into many astronomers' minds was, why would a comet arriving from interstellar space, a region untouched by our sun's radiation for billions of years, be glowing so strongly? The simplest explanation pointed to unusual concentrations of carbon-based molecules, but that didn't solve the mystery. If anything, it deepened it, because it implied that Atlas formed under conditions unlike those of most other comets we've seen. Then came the real shock. Spectral analysis revealed that Atlas contained nickel emission lines, but virtually no iron. To the untrained ear, that might sound trivial, but in astrophysics, nickel and iron are like inseparable twins. They're born together in the same supernova explosions, formed in the fiery cores of massive stars. Wherever you find one, you expect to find the other in similar proportions. Yet here was Atlas, flaunting nickel while leaving iron behind. This wasn't just odd, it was unheard of. Some suggested contamination or instrument error, but repeated observations confirmed the finding. For many scientists, it was a red flag waving across the cosmos, shouting that Atlas wasn't following the same rules as ordinary comets. If nickel could exist in isolation, where had it come from? What kind of stellar nursery or catastrophic event could have produced such a chemical profile? The answers weren't clear, and that uncertainty made Atlas far more intriguing than its faint glow suggested. While Atlas baffled researchers with its chemistry, Swan R2 turned the confusion into chaos. Its sheer brightness allowed for detailed spectroscopy, and what scientists found was a volatile cocktail of compounds streaming from its surface. It released water vapor and carbon dioxide at rates far beyond what models predicted, making it brighter and more active than almost any comet in recent memory. But it wasn't just the amount of gas, it was the speed and violence of its release. Jets erupted unpredictably, almost as if the comet's surface were under artificial pressure. Some researchers speculated that Swan R2 contained unusual internal structures, perhaps massive pockets of volatile ice that ruptured as it neared the sun. Others couldn't shake the suspicion that its activity was too dramatic, too staged, like fireworks timed for effect. The combined chemical mysteries of Atlas and Swan R2 forced scientists to revisit long-standing assumptions. If these were natural interstellar objects, they should conform to the general chemistry of the galaxy, familiar ratios of metals, gases, and organics. Instead, each object seemed to carry its own anomalies. Atlas flaunted a bizarre absence of iron. Swan R2 produced activity at levels that seemed exaggerated, and together they arrived like actors playing complementary roles, one quiet and strange, the other loud and flamboyant. Was this simply coincidence, or were we staring at signatures of something more deliberate? The theories that emerged ranged from the cautious to the sensational. On the cautious side, some argued that Atlas may have formed in a disk around a young star with unusual elemental ratios, one that produced nickel-rich but iron-poor debris. Others suggested Swan R2 could have been destabilized by collisions in its home system, carrying fractures and voids that made it more volatile. Yet these explanations felt stretched, as though scientists were bending natural laws to fit the data. On the more speculative side, whispers grew louder that the anomalies could be signs of something artificial. If an advanced civilization wanted to disguise a probe as a comet, what better way than to mimic the chemistry of a natural one, while hiding in plain sight behind the limits of our instruments? The green glow of Atlas might be more than chemistry. It could be the explosive activity of Swan R2 might be more than gas pockets. It could be controlled venting. The nickel without iron puzzle might not be natural at all, but the fingerprint of exotic materials unknown to us. Official agencies, of course, dismissed such talk as conspiracy thinking. NASA and ESA released statements stressing that while the chemistry was unusual, there was no evidence of anything artificial. But even in their measured tones, they used words like exotic and rare, language that carried a subtle weight. Because in science, when experts call something exotic, it's often code for we don't understand it yet. And in this case, the lack of understanding left plenty of room for speculation. The public, meanwhile, ran with the mysteries in every direction. Online forums buzzed with theories that Atlas was a scout, mapping the solar system with instruments hidden in its glowing coma. Others argued Swan R2 was the main event, an enormous vessel cloaked in dust and gas, its chemical fireworks a distraction from whatever lay at its core. Some even suggested the pair were coordinated, one to test our detection systems, the other to test our response to a bright, undeniable visitor. The lack of definitive answers fueled the fire, leaving the line between science and speculation increasingly blurry. One detail that kept resurfacing was how chemistry, in theory, should be universal. Hydrogen behaves the same way in every corner of the cosmos. Carbon bonds the same way, whether on Earth or in a galaxy millions of light years away. So when something breaks those rules, the scientific instinct is to dig deeper. With Atlas and Swan R2, the rules seemed broken in ways that weren't easy to write off. Nickel without iron, glow without sufficient solar heating, activity without predictable cause. Each anomaly was like a puzzle piece that didn't fit the larger picture of cosmic chemistry. And when puzzle pieces don't fit, you have to wonder if the puzzle itself is the wrong one. By the end of the first wave of studies, scientists were left with more questions than answers. Were Atlas and Swan R2 natural but extremely rare outliers, products of environments we simply hadn't studied before? Or were they signals of something more profound, evidence that intelligence elsewhere in the universe had found a way to manipulate matter at levels we couldn't yet comprehend? The truth was unclear, but the chemical mysteries refused to be ignored. If chemistry is the fingerprint of creation, then both Atlas and Swan R2 were smudged prints, leaving us unsure of what hand had left them behind. And as both objects continued their journeys toward the blinding light of the sun, one fact became undeniable. Whatever secrets they carried, the timing of their arrival made sure we'd have the least chance to uncover them, almost like the cosmos or something within it wanted to keep those mysteries hidden just a little longer. When two separate interstellar visitors arrive in the same neighborhood of space within weeks of each other, the first reaction from scientists is usually to dismiss it as nothing more than chance. After all, the universe is vast, full of drifting fragments of rock and ice that move silently between stars, and eventually some of them are bound to stumble into our solar system. That explanation works fine for one object, maybe even two spread years apart, like Oumuamua in 2017 and Borisov in 2019. But with 3IATLAS discovered on July 4, 2025, and Swan R2 spotted on September 11, 2025, the timing feels almost too neat. One faint, green, chemically bizarre wanderer slipping into our vision just in time to make headlines, followed by a blazing spectacle with a million-kilometer tail announcing itself across the night sky. Both completely unrelated, both hailing from different directions, both moving on hyperbolic trajectories that prove they are visitors from beyond our star. The official explanation says coincidence, but the deeper you dig into the numbers, the less convincing that sounds. Statistically, the chance of two interstellar objects arriving in such close succession is almost vanishingly small. Some estimates put the odds at 1 in billions, depending on how you run the models. Interstellar objects are rare visitors, and our ability to detect them is even rarer, limited by telescope coverage and the brief windows when they are visible. For two to arrive less than 3 months apart is the equivalent of lightning striking the same place twice, not in a decade, but in the same hour. Coincidences do happen, but this level of improbability makes people wonder whether there's more going on than simple random chance. And when people start wondering, the imagination rushes in to fill the gaps science cannot yet explain. One of the most unsettling aspects of this timing is that Atlas and Swan R2 are not alike in character. If they had been two faint objects discovered only by professionals combing through telescope data, the coincidence might have gone unnoticed outside of academic circles. But Atlas is dim, strange, carrying a chemical fingerprint that defies expectations, while Swan R2 is blindingly bright, volatile and impossible to ignore. It's as if one object was designed to test the limits of our instruments, while the other was designed to capture the attention of every human on Earth who happened to look up. Together they form a yin-yang of cosmic anomalies, one subtle, one spectacular. The more you look at them side by side, the less they feel like random arrivals and the more they resemble a coordinated sequence. Skeptics argue that human beings are simply wired to see patterns in chaos, to connect dots that have no real relationship. And there's truth to that. We find shapes in clouds, faces in shadows, meaning in coincidences, but history reminds us that sometimes patterns are real. When two events occur close together, even if unrelated, their psychological impact multiplies. The coincidence of Atlas and Swan R2 doesn't just stir curiosity, it amplifies fear. People wonder if we are being observed, if we are part of a larger story unfolding just beyond our understanding. And when fear and wonder collide, civilizations craft myths, rumors, and suspicions. This has happened before with comets throughout history, seen as omens of war, famine, or great change. But in the modern age, with technology capable of peering deep into the chemical makeup of these objects, the unease takes on a sharper edge. We aren't just frightened of what they might symbolize, we're unsettled by the possibility that they are more than symbols. The coincidence also raises questions about what might be called cosmic timing. Why now, in the early 21st century, when humanity has finally developed the technology to detect, analyze, and debate such phenomena in real time? Why not centuries ago, when these visitors would have passed unnoticed except as fleeting lights in the sky? It's almost as if they arrived precisely when our instruments and our collective imagination were ready to grapple with their implication. That sense of timing has fueled speculation ranging from the scientific to the fantastical. Some theorists suggest that interstellar space may contain streams of debris, rivers of icy fragments ejected from ancient star systems, and perhaps Atlas and Swan R2 simply belong to the same stream passing near our sun. Others go further, imagining them as deliberate arrivals, probes dispatched long ago now appearing in concert like actors entering a stage. If you lean on the natural explanation, you can take some comfort in models that predict interstellar visitors may not be as rare as we once thought. Perhaps we are simply getting better at spotting them, and what feels like coincidence is actually just improved detection. That argument has weight, but it still doesn't erase the uncanny timing. For most of human history, no one could confirm the existence of a single interstellar object. Then, within less than a decade, we detect four: Oumuamua, Borisov, Atlas, and Swan. That sudden spike doesn't just feel like better technology, it feels like the universe has suddenly decided to send us messengers all at once. And the strange thing about messages is that they are rarely random. The coincidence grows stranger when you consider the observational blind spots built into their trajectories. Both Atlas and Swan R2 make their closest approaches while Earth's telescopes are blinded by the sun's glare. This means that just as they pass closest, just as we could have learned the most, we lose sight of them. That kind of timing is infuriating for scientists, who want every possible chance to collect data. But for those inclined to suspicion, it feels like more than bad luck. It feels like design. If these were probes deliberately sent or steered, wouldn't they choose a trajectory that keeps their secrets hidden during their most vulnerable moments? Wouldn't they slip past while we're looking away, leaving us with only fragments of their story? Even the psychology of coincidence plays a role in how people view this. When things line up in ways we can't explain, we search for meaning, even when none exists. Yet here, the coincidence isn't just about timing, it's about chemistry, visibility, and opportunity all aligning in a way that defies the odds. One object arrives faint and chemically bizarre, another arrives blazing and unpredictable. Both slip into invisibility just when it matters most. Put all of that together, and the word coincidence feels increasingly inadequate. If this were a chessboard, it would look less like random moves and more like strategy. The scientific community has largely resisted the urge to embrace anything beyond natural explanations. They caution against overinterpretation, reminding the public that space is vast, probability is slippery, and coincidences can and do happen. Yet even among scientists, some admit privately that the back-to-back arrivals of Atlas and Swan R2 feel uncanny. They use phrases like unprecedented, statistically extraordinary, and extremely unusual, and when those words leave the mouths of professionals trained to downplay sensationalism, you know the unease is real. Ultimately, the cosmic coincidence of Atlas and Swan R2 forces us to confront one of the deepest questions in science. How much of what we see is random, and how much carries hidden meaning? Are these objects simply two wanderers, their paths aligned by nothing more than chance? Or are we living through a moment in which the universe, or perhaps something within it, has decided to draw our attention in the most dramatic way possible? Whatever the answer, the arrival of Atlas and Swan R2 side by side reminds us that sometimes the cosmos writes stories so improbable that we can't help but feel like characters inside them. And as their journeys continue into the glare of the sun, one thing is certain: the coincidence that brought them here will echo in our imaginations long after their light has faded. Astronomy is often described as the science of light, but what that really means is that our understanding of the universe depends on when and where that light reaches us. We build massive observatories, launch satellites beyond Earth's atmosphere, and construct radio dishes that sweep the heavens, all in a desperate attempt to capture faint signals drifting across unimaginable distances. Yet, even with all of our technology, our vision remains fragile. Sometimes the universe simply refuses to reveal its secrets. That truth has never felt more frustrating than with the arrivals of 3IATLAS and Swan R2, two interstellar wanderers, whose most important moments unfold precisely when our instruments are least able to observe them. To astronomers, this is the cruel irony of timing. To skeptics, it feels like something more, like an intentional trick built into their trajectories. When Atlas was first spotted in July 2025, excitement buzzed through the scientific community. Here was only the third confirmed interstellar object in human history, glowing faintly green and carrying a strange chemical fingerprint. Naturally, astronomers wanted to track it as closely as possible, to gather every scrap of data before it slipped back into the depths of space. But orbital calculations delivered a gut punch. Atlas was set to make its closest approach to the Sun in early October, just as Earth's line of sight would be drowned in solar glare. In other words, at the exact moment scientists most needed clear, high-resolution observations, our planet's vantage point would be blinded. Ground-based telescopes would be useless. Even many space-based instruments would struggle, their sensors overwhelmed by the sun's brilliance. Atlas would pass by in the one part of the sky where our vision is weaker. It's like watching a stranger walk past your window at night and then vanish into a patch of shadow, leaving you with only a glimpse of their silhouette. The frustration only deepened with Swan R2. Discovered in September, its trajectory revealed another cruel coincidence. It too would reach closest approach in late October, again slipping directly into the sun's glare. Unlike Atlas, Swan R2 was bright and flamboyant, visible even to backyard observers. But as it moved toward the most critical part of its journey, Earth's telescopes would once again be forced to look away, blinded by the one star we cannot ignore. For professionals who dedicate their lives to capturing every photon of light, this felt like a cosmic insult. To casual observers, it looked like a cover-up by the universe itself. How could two unrelated objects, arriving at nearly the same time, both choose paths that shield their closest moments from our eyes? Of course, the rational explanation is orbital mechanics. Objects from interstellar space follow hyperbolic paths shaped by gravity, not human convenience. They do not care about our vantage point or our desires. If they pass behind the sun from our perspective, that is nothing more than geometry. Yet even with that explanation, the sense of unease lingers, because while it may be geometry, it is also improbability layered upon improbability. Not only did Atlas and Swan R2 arrive within months of each other, not only did they display bizarre chemical and physical behavior, but they also managed to time their arrival so that Earth would be effectively blind during their closest approaches. Statistically, each piece might be explainable, but together, the pattern feels almost orchestrated. Scientists, being practical, try to work around these blind spots. Mars, after all, would be in a much better position to observe Atlas during its closest pass. The European Space Agency's Trace Gas Orbiter, along with NASA's Mars Reconnaissance Orbiter, and even the aging Mars Express, would all be in prime locations to watch. For a brief moment, excitement flared. Humanity would finally get to study an interstellar object up close, not from Earth, but from another planet. It was a poetic reminder of how far we had come, with robotic emissaries stationed around Mars ready to do the work Earth could not. Yet even this opportunity carried its own shadow. Data from Mars orbiters is not instantaneous. It must be captured, transmitted, processed, and eventually released, and that delay, however normal in scientific work, leaves space for doubt. What if some of the data never makes it public? What if key observations are lost, misinterpreted, or quietly set aside because they don't fit the narrative of nothing unusual here? To those already suspicious of the timing, the Mars solution was hardly comforting. It only added another layer of distance between the truth and our eye. Meanwhile, Swan R2's path offered no such consolation. Its closest approach on October 21 would take it within 40 million kilometers of Earth, close enough to stir unease, but still far enough to pose no direct threat. Yet that very moment of proximity, when its massive tail and volatile jets could be studied in unparalleled detail, would be invisible to us. Our instruments, overwhelmed by the sun, would miss the spectacle. By the time Swan R2 emerged from the glare, much of its story would already be written in light we never captured. Scientists would be left piecing together fragments, trying to reconstruct an event they never fully saw, and in that blindness lies the fertile ground for speculation. History reminds us that blind spots often fuel myths. Ancient civilizations, unable to explain eclipses or strange lights in the sky, turned their ignorance into stories of gods and omens. In the modern age, we pride ourselves on science, yet we are not immune to the same instincts. When knowledge slips beyond our reach, imagination rushes in. Already, whispers circulate that Atlas and Swan R2 are not merely passing objects, but deliberate arrivals, designed to slip past our gaze at the most critical moments. Some say the timing ensures that we never see their true nature, that whatever lies at their cores remains hidden in solar shadow. Others argue that this is proof of intelligence, that if a probe were masquerading as a comet, it would choose a path that minimizes the chance of discovery. After all, what better camouflage than to appear when your observers are literally blinded by their own star? Even within scientific circles, the frustration over these blind spots has given way to uneasy language. Terms like unfortunate timing, critical observational gaps, and lost opportunities appear in papers and briefings. These are not the words of people satisfied with coincidence. They are the words of researchers aware that their quarry has slipped away at the moment of truth. For some, this is simply the harsh reality of astronomy. You don't always get to choose the conditions under which discoveries happen. For others, it is a reminder of how vulnerable our understanding remains, how little control we have over what the universe chooses to reveal. And yet, perhaps that vulnerability is the point. Blindness forces us to confront not just the limits of our instruments, but the limits of our certainty. Atlas and Swan R2 arrived in rapid succession, carrying mysteries in their chemistry, their behavior, and their timing. But by disappearing into the glare of the sun at their closest passes, they added one more layer of strangeness. They denied us the clarity we craved. They left us in the dark, quite literally, at the very moment when the light should have told the truth. Whether that denial was cosmic accident or cosmic schism, no one can say for sure. What we can say is that the blind spots in our observation did more than block our view. They opened a void of speculation, a space where science, imagination, and fear all collided. And as history shows, when the universe hides its secrets, humanity does not stop asking questions. Instead, we ask louder, more urgently, desperate to fill the silence with meaning. While Earth finds itself blinded by the sun during the critical moments of 3IATLAS's closest approach, another planet stands in a much better position to watch. Mars. For the first time in human history, the red planet becomes our cosmic lookout, offering a vantage point Earth simply cannot achieve. In many ways, this is a twist worthy of myth. Mars, the planet we've long associated with war, mystery, and future colonization, suddenly holds the key to unraveling one of the strangest interstellar events of our time. And the irony isn't lost on scientists. The very spacecraft we've stationed around Mars, machines built for studying the Martian atmosphere, surface, and climate, are now being called on to witness something far beyond their original mission. They have become our accidental astronomers, ready to record Atlas as it passes closer to them than to us. For years we've sent robots to Mars to search for life, but now those same machines may help us determine whether something truly alien is passing through our solar system. The European Space Agency's Trace Gas Orbiter is one of the most promising tools for this task. Designed to sniff out methane and other chemical signatures in the Martian atmosphere, it carries sensitive instruments capable of analyzing light with exquisite precision. When Atlas sweeps past, its strange green glow and unusual nickel-heavy spectrum will be in full view of the orbiter's sensors. Unlike Earth, where solar glare blinds our telescopes, Mars will be offset just enough to enjoy a relatively clear vantage. The possibility of collecting data without interference from the sun has astronomers salivating. Imagine capturing high-resolution spectra of Atlas's coma and tail, unraveling its bizarre chemistry in detail never before possible. This is the kind of opportunity that can rewrite text. Yet even as scientists prepare, there's a gnawing awareness that the data may raise more questions than it answers. NASA's Mars Reconnaissance Orbiter, though older, also brings powerful tools to the table. Its HiRISE camera has been used to photograph objects on the Martian surface as small as a dining table, and while it wasn't built for deep space astronomy, its precision could be repurposed. Even the aging Mars Express, still operational after 2 decades, may contribute observations. The collective capability of these orbiters gives humanity a rare second chance to study an interstellar object up close. But here's where the story grows more complicated. Data from Mars does not flow instantly to Earth. Every packet of information must travel millions of kilometers, relayed through the deep space network, processed by mission teams, calibrated, and only then released to the broader scientific community. In most cases, this is a routine process, one that ensures accuracy and quality, but in situations as unusual as this, delays can feel ominous. What if some of the data never sees the light of day? What if anomalies too difficult to explain are quietly set aside? Officially, such censorship doesn't happen. Unofficially, suspicion thrives in the gaps. The Mars advantage, then, is not just a technical edge, but a psychological one. For the first time, we are forced to admit that our vision of interstellar visitors is no longer Earth-centered. We are reliant on another planet's machines to tell us what is happening in our own solar system. That shift alone is historic, symbolizing humanity's gradual step toward becoming a multiplanetary species. Yet it also underscores our vulnerability. If the Mars orbiters detect something truly inexplicable, say, emissions inconsistent with natural chemistry, or structural anomalies that suggest artificial design, how would the world react? Would scientists publish such a finding immediately, or would they hesitate, knowing the implications could shatter long-held beliefs about our place in the universe? Adding to the drama is the fact that Atlas passes relatively close to Mars itself. Not close enough to pose a danger, but near enough to give orbiters a front-row seat. Imagine a probe disguised as a comet drifting silently past the very machines we placed on another planet to search for life. The symbolism is almost poetic. Life searchers becoming witnesses to something that could redefine life itself. If there were ever a moment to prove that we are not alone, this would be it. Yet paradoxically, the very circumstances that make Mars an ideal observer also mean Earth remains largely in the dark. By the time we receive the full set of data, Atlas will already be receding into the void, its secrets hidden once again. The story doesn't end with Atlas, of course. Swan R2, the flamboyant second visitor, is also affected by the Mars advantage, though in different ways. While Earth is blinded during its closest pass, Mars may again enjoy better conditions for observation. This sets up a strange dynamic. Our neighboring planet may end up being the primary witness to both interstellar events, while Earth, the birthplace of human science, misses its chance. To many, this feels like cosmic irony. For centuries, humanity has gazed at Mars through telescopes, dreaming of its secrets. Now the roles are reversed. Mars, through our robotic emissaries, gazes at the cosmos for us, capturing the secrets we cannot see. Of course, not everyone views this as a triumph. Some see it as suspicious. If Atlas and Swan R2 were natural, why should their closest approaches align with Earth's blind spots but Mars's clear view? Is this pure coincidence, or something more deliberate? Skeptics argue that if these objects were probes, their navigators might want to avoid direct scrutiny from Earth, where the largest concentration of advanced instruments resides. At the same time, allowing Mars a less scrutinized, a less politically entangled vantage to record them would provide just enough data to keep suspicion alive without delivering definitive proof. In other words, the Mars advantage might be less about science and more about misdirection. Even if you reject such theories, the sense of unease persists. Scientists are trained to crave data, but in this case the data feels precarious. It relies on machines far from home, vulnerable to transmission errors, and subject to human decisions about what to prioritize. If Mars orbiters capture something extraordinary, the world may never know until much later, if at all, and that delay leaves fertile ground for speculation. Conspiracy theorists will claim the truth is being hidden. Optimists will argue that extraordinary revelations are on the way. Realists will point out that most of the time, unusual data turns out to have mundane explanations. But in this case, the combination of rarity, timing, and the sheer strangeness of the objects ensures that every gap in knowledge will be filled by imagination. Ultimately, the Mars advantage highlights both the power and the fragility of our scientific reach. On one hand, it proves that humanity has extended its senses beyond Earth, stationing eyes and ears on another world to study the cosmos. On the other, it reminds us how easily we can be blinded, how much we depend on a handful of machines millions of kilometers away. The arrival of Atlas and Swan R2 has forced us to recognize that we are still at the mercy of perspective. From Earth, we see shadows and fragments. From Mars, perhaps we will see more. But whether what Mars sees will bring clarity or deepen the mystery remains unknown. What is certain is that the red planet has, for a brief and eerie moment, become our cosmic witness, and as humanity waits for its testimony, the question hangs heavy in the air. What if Mars confirms what Earth cannot bear to see? If Atlas was strange, Swan R2 is something else entirely. From the moment it was detected, astronomers noticed it didn't behave like any comet we've catalogued before. Its brightness surged suddenly, far faster than the slow increase typically seen as icy bodies approach the Sun. In a matter of days, it went from a faint object lost in the background noise of space to one of the brightest interstellar visitors ever recorded, stretching a glowing tail so long that even seasoned observers were unsettled. And this wasn't just a beautiful astronomical display. To some it looked like a warning, as though Swan R2 were not simply passing through but announcing its presence in a way no one could ignore. The timing, coinciding so closely with 3IATLAS, only made the spectacle feel more deliberate, more orchestrated, as though these two objects were performing a cosmic dance with Earth caught at the center of the stage. The most unsettling aspect of Swan R2 was its instability. Unlike Atlas, whose strange green hue and nickel-heavy composition gave it an alien aura, Swan R2 seemed restless, as if struggling to hold itself together. It erupted with outbursts, blasting jets of gas and dust that caused its brightness to spike unpredictably. Astronomers know comets can flare, but Swan R2 did it with unnerving regularity, almost like pulsing. To conspiracy theorists, those pulses were signals, timed emissions directed outward into the void, or worse, aimed at us. To scientists, they were a puzzle. No model could fully explain why Swan R2 was burning through its material so quickly, or why its core seemed so volatile. Some predicted it would disintegrate long before reaching perihelion, yet each time it appeared to dim, it rebounded with even greater intensity, as if fueled by something beyond simple ice and rock. Then came the trajectory issue. Swan R2 didn't follow the smooth, predictable path expected of a comet. Tiny but measurable deviations cropped up in its orbit, defying the expected gravitational and solar radiation pressures. NASA publicly attributed these to uneven jets of material erupting from its surface, a reasonable explanation on paper. But behind the scenes, even seasoned astronomers admitted the shifts were too consistent, too clean, as though the object was subtly adjusting its course. It reminded some of Oumuamua, the first confirmed interstellar object discovered in 2017, which also displayed anomalous accelerations that sparked debates over whether it was a natural rock or an alien probe. Swan R2, however, was even more dramatic, larger, brighter, and far more erratic. And unlike Oumuamua, which zipped past quickly and silently, Swan R2 demanded attention, dancing across the sky in ways that seemed designed to provoke. For people watching from Earth, the spectacle was breathtaking but unsettling. Social media lit up with photos of the comet's enormous tail spreading like a cosmic banner against the stars. Amateur astronomers reported strange flickers and patterns within the glow, almost like coded shapes emerging for brief moments before dissolving back into dust. Of course, most scientists dismissed such claims as optical illusions, artifacts of overexposed cameras, or turbulent atmospheres. But the rumors spread anyway, fueled by the already eerie coincidence of two interstellar visitors arriving together. Some saw Swan R2's brilliant tail as a celestial omen, echoing ancient beliefs that comets herald disaster or change. Others whispered that it was a deliberate display, a show of force or communication meant for whoever was watching. After all, if you wanted to be noticed across light years, wouldn't you make yourself shine as brightly and erratically as possible? The real anxiety came from Swan R2's approach path. Unlike Atlas, which kept a relatively safe distance, Swan R2's trajectory appeared more threatening. Early models suggested it would pass uncomfortably close to Earth, within a range where any unexpected breakup could scatter debris directly into our orbital neighborhood. Space agencies worked quickly to calm the public, emphasizing that the current trajectory posed no collision threat, but the language was careful. Phrases like "no significant risk" and "unlikely to pose danger" did little to silence those who feared the worst. After all, if Swan R2 could shift its orbit unpredictably, how could anyone guarantee safety? The constant outbursts only added to the uncertainty. A single large fragmentation event could alter its course dramatically, and while the odds of an impact remained low, the fear lingered. Adding fuel to the fire was the green glow of Atlas, still fresh in public memory. Two bizarre interstellar objects, both behaving strangely, both timed to arrive within weeks of each other, and one now approaching dangerously close. This was enough to ignite theories ranging from alien reconnaissance missions to apocalyptic predictions. Even mainstream media, normally cautious about indulging such speculation, couldn't resist. Headlines framed Swan R2 as the comet that refuses to behave, a cosmic wildcard, or the second act of a mysterious show. Scientists, meanwhile, walked a tightrope. They wanted to study the object, publish findings, and calm fears, but they also had no answers for the deeper questions gnawing at the public imagination. Why now? Why two at once? And why such strange behavior? Behind the scenes, military interest in Swan R2 grew quickly. Satellites were tasked with monitoring its approach, not just for scientific reasons, but for national security. Some feared that if the object displayed signs of artificiality, structured emissions, anomalous maneuvers, or even radio signals, its implications could destabilize global politics overnight. Was Swan R2 a natural wanderer from deep space? Or was it a messenger, or worse, a weapon sent by an intelligence far beyond us? Publicly, officials avoided such talk. Privately, contingency plans were drafted. In a world already shaken by uncertainty, the idea of an alien object making a close pass to Earth was enough to trigger hushed emergency meetings in corridors of power. Yet, through all the fear and speculation, there was awe. People who saw Swan R2 with their own eyes described it as life-changing, a reminder of how small we are and how vast the universe is. Children asked if aliens were coming. Artists painted its glowing arc across the night. Poets likened it to a cosmic flame burning against eternity. Whatever Swan R2 truly was, it had captured human imagination in a way few celestial events ever have. And maybe that was the most important part of its dance. It forced us to look up again, to question, to wonder if we are truly alone, or if the universe had finally decided to answer back. Still, the uncertainty gnawed. Each day brought new measurements, new spikes in brightness, new whispers of orbital anomalies. Every flare, every deviation was dissected by both scientists and conspiracy theorists alike. And through it all, the question persisted. Was Swan R2 just another strange but natural comet, or was it something far more deliberate? The truth remained elusive, hidden behind dust, gas, and the glare of speculation. But one thing was certain: Swan R2 wasn't just passing through quietly. It was performing, demanding attention, as though the universe itself had orchestrated a spectacle designed to unsettle and inspire. And as it drew closer to Earth, the sense of unease only deepened, because no one could predict its final act. Would it disintegrate harmlessly, fade into obscurity like so many comets before it? Or would its threatening dance end with a twist that would change everything we thought we knew? The arrival of 3IATLAS and Swan R2 together ignited a storm of theories that spread across scientific circles. media outlets, and online communities like wildfire. For the public, the strange behavior of these two interstellar objects, one glowing an unearthly green and the other bursting with erratic brilliance, was too peculiar to explain away with ordinary science. For scientists, the coincidences stacked up so high they were forced to tread carefully in their public statements, offering cautious words about unusual but natural phenomena, while privately admitting to each other that the odds seemed almost impossible. In such an environment, theories multiplied, ranging from the plausible to the outrageous, each one attempting to explain what none of us could fully understand. The most conservative explanation, of course, was that this was all natural, a rare but not impossible alignment of cosmic events. After all, the universe is vast, and interstellar objects must wander through solar systems all the time. The discovery of Oumuamua in 2017 and Borisov in 2019 had already proven that outsiders regularly pass through our neighborhood. By that logic, perhaps Earth was simply experiencing a statistical fluke, two chance arrivals overlapping in time. But even among scientists, this explanation felt hollow. The simultaneity of Atlas and Swan R2, combined with their bizarre chemical signatures and unpredictable behavior, stretched the boundaries of coincidence to the breaking point. Statistical anomalies happen, yes, but two at once, so spectacularly, and both perfectly timed to arrive when Earth's telescopes were blinded by the sun. Even skeptics admitted it was a lot to swallow. The next tier of speculation veered into more exotic territory. One theory suggested that Atlas and Swan R2 were fragments of the same parent body, perhaps a shattered interstellar object ejected from its home system eons ago. According to this idea, they had traveled together across unimaginable distances, bound not by proximity but by shared origin, and their near-simultaneous arrival at Earth was no accident. It was the end of a long journey that had always been linked. While this theory added a layer of romance to the mystery, it still failed to explain the odd behaviors. How could two fragments of the same object end up with such radically different appearances, one glowing green with metallic traces and the other erupting like a cosmic beacon? And if they had traveled together for millions of years, why did they approach from opposite directions? The contradictions made this theory more poetic than scientific, but it remained popular among those who wanted a natural explanation without invoking pure chance. Then came the darker speculations, the ones that suggested intelligence might be at play. The anomalous orbital shifts, the unpredictable pulses of gas from Swan R2, the spectral oddities of Atlas. All of these were reinterpreted through the lens of artificiality. What if these weren't just rocks and ice, but machines disguised as natural bodies? The concept wasn't new. Avi Loeb, a Harvard astronomer, had famously argued that Oumuamua could have been an alien probe, citing its strange acceleration and thin, elongated shape. Though his ideas were controversial, they had laid the groundwork for a broader acceptance of what if. With Atlas and Swan R2 behaving even more erratically than Oumuamua, whispers of alien technology resurfaced with renewed intensity. Some imagined reconnaissance devices, scouting solar systems and gathering data. Others pictured beacons, transmitting signals encoded in their light. The most unsettling theory suggested they could be weapons, designed to disguise themselves as comets until the moment they revealed their true purpose. Of course, mainstream scientists avoided these suggestions in public, but the internet thrived on them. Forums filled with diagrams claiming to decode patterns in Swan R2's brightness spikes. Amateur radio astronomers claimed to detect strange bursts of noise when pointing antennas toward Atlas, though most professionals dismissed this as interference. Still, the sense of unease spread. If these objects were probes, why two at once? Were they scouting us in stereo, triangulating Earth's defenses from multiple directions? Or were they emissaries from different civilizations coincidentally converging on our system at the same time? To some, the idea of a galactic coincidence was even more terrifying than a coordinated plan. Another theory, popular in fringe circles, tied Atlas and Swan R2 to ancient myths and prophecies. Throughout history, comets have been seen as omens, symbols of upheaval and transformation. From the fall of empires to the rise of new religions, glowing streaks in the sky have always captured human imagination. According to this line of thought, the simultaneous arrival of two spectacular comets was not random. It was a cosmic signal. Some pointed to Mayan prophecies, others to biblical references about stars falling from the heavens. The eerie green of Atlas was interpreted as a harbinger of sickness or renewal, while Swan R2's fiery brilliance symbolized war or rebirth. Though few scientists gave these theories credibility, they resonated deeply with the public, especially in a world already gripped by uncertainty. Sometimes belief itself can be more powerful than evidence. There were also whispers about cover-ups. If Mars orbiters were indeed in the perfect position to observe Atlas and Swan R2 while Earth remained blinded, then governments had access to information the public did not. What if the data already contained anomalies too strange to share openly? What if officials were sitting on proof of artificiality, waiting for the right moment to disclose or bury it? These suspicions grew stronger every time space agencies released vague updates, filled with careful phrases and hedged language. Unusual chemical composition, unexpected orbital variations. Further analysis needed. To a suspicious mind, such wording sounded less like science and more like stalling, and in the absence of clarity, speculation filled the void. At the more philosophical end, some theorists argued that Atlas and Swan R2 were not intrusions at all, but invitations. Perhaps they were not scouts or weapons, but messengers, physical embodiments of communication from a distant civilization. Instead of sending fragile radio waves, which might dissipate over cosmic distances, an advanced species could have launched self-sustaining messengers, comets infused with signals or artifacts, designed to wander until they encountered intelligent observers. In that light, the timing wasn't a coincidence. Earth, now bristling with telescopes, satellites and space probes, had finally reached a level of technology capable of noticing them. The messengers had arrived exactly when they were meant. This theory, while speculative, reframed the entire event as part of a grander design, making humanity not an accidental witness, but the intended recipient of a galactic communique. Yet even this hopeful vision carried unsettling undertones. If these were messengers, what was their message? A greeting, a warning, a test? And if we deciphered it, would we regret the answer? The universe is vast, and intelligence elsewhere might not think or feel as we do. Their priorities could be incomprehensible, their values alien. Perhaps Atlas and Swan R2 were not emissaries of peace, but markers, signals to others that this small blue planet had reached awareness and was now ready, or vulnerable for contact. Through all these theories, one theme kept surfacing: uncertainty. Every time scientists measured Atlas's green glow or tracked Swan R2's erratic pulses, they found more questions than answers. Every official statement seemed cautious, every unexplained anomaly magnified by the imagination of millions. Humanity was caught in a strange limbo, aware enough to recognize the significance of these objects, but not advanced enough to fully explain them. And in that gap between knowledge and mystery, speculation thrived. Some people found comfort in natural explanations, others found fear in artificial ones, and still others found meaning in myth. But no one could look at the sky without wondering if the story unfolding above was far bigger than we could comprehend. What made it worse or better, depending on perspective, was that the show wasn't over. Both Atlas and Swan R2 were still inbound, still changing, still surprising us with every new observation. And as long as they remained unpredictable, the theories would only multiply. Natural flukes, shattered siblings, alien probes, cosmic omens, messengers of destiny, every possibility remained on the table. And the truth, whatever it was, hovered just out of reach, waiting for the right moment to reveal itself. Whenever strange phenomena appear in the skies, the public looks to scientists for answers, but governments and militaries are always watching in the background. With the arrival of 3IATLAS and Swan R2, that watchfulness transformed into something far more intense, something secretive, deliberate, and unnerving. From the moment the two objects were confirmed, space agencies rushed to reassure the public that they posed no threat. Statements emphasized natural origins, statistical improbabilities, and the beauty of astronomy. But behind the calm words, the machinery of national defense and global intelligence was already grinding into motion. These were not just scientific curiosities anymore. They were potential threats, potential opportunities, and potential turning points in human history. The first sign came in the form of restricted data. Amateur astronomers have long prided themselves on tracking comets independently, often spotting anomalies before professionals. But in this case, observers quickly noticed gaps. Certain raw feeds from telescopes went offline without explanation, replaced by sanitized summaries. Space weather networks delayed updates. Even the usually transparent Minor Planet Center, which compiles global tracking data, became unusually cautious with the numbers it released. For the conspiracy-minded, this was proof enough. Governments were holding back something extraordinary. For others, it was simply unsettling. After all, if Atlas and Swan R2 were just comets, why was information suddenly being managed so tightly? Militaries around the world quietly redirected assets toward the interstellar visitors. High-orbit satellites were tasked with spectral monitoring. Classified telescopes, normally used for tracking space debris or rival nations' satellites, were repointed to capture data on the comets. Even radar systems, designed to detect missiles, were briefly tested against the strange objects. This was not simply curiosity, it was reconnaissance. The concern was not that Atlas or Swan R2 would collide with Earth, but that they might not be what they appeared. If either object showed signs of controlled carrier communication or artificial structure, the implications would upend the balance of global power. In the shadows, generals and intelligence chiefs asked themselves chilling questions. What if these objects were probes? What if they belonged to someone or something not from Earth? And if so, what should humanity do? Within these discussions, a deep divide emerged. On one side were those who saw Atlas and Swan R2 as a threat, possibly hostile reconnaissance devices. To them, the anomalies in trajectory and emissions hinted at artificiality, and the worst-case scenario had to be assumed. If these were alien scouts, they could be gathering intelligence before something larger arrived. Such voices argued for preparation, defense systems on alert, contingency plans drafted, and international coordination tightened, even if the public could never be told the full truth. On the other side were those who viewed the objects as opportunities, not dangers. If they were probes, they represented the first confirmed evidence of intelligent life beyond Earth, something humanity had dreamed of for centuries. Instead of secrecy and suspicion, these optimists argued for open data sharing and rapid scientific analysis. Yet optimism is rarely the language of military rooms. Fear speaks loud. Meanwhile, agencies with long histories of monitor and identified aerial phenomena, NASA, the Pentagon, Roscosmos, and even China's CNSA, began cross-checking the anomalies. The nickel-heavy emissions of Atlas raised eyebrows, natural perhaps, but unusually concentrated. Swan R2's orbital wobbles were even more concerning. Were these just the results of gas jets erupting from an unstable core, or were they micro-adjustments as if the object was steering? Official reports leaned heavily on natural explanations, but private briefings painted a more ambiguous picture. The phrase, low-confidence anomaly, began appearing in classified memos, a bureaucratic way of saying, we don't know what's going on, but it could be something big. The involvement of Mars orbiters added another layer of intrigue. With Earth blinded by the sun during the most crucial windows, humanity's best eyes on the objects came from machines orbiting another planet, but the data they collected flowed first to space agencies, then through layers of government review, before ever reaching the public. That delay, while standard in routine science, took on a darker tone here. What if those orbiters had already captured evidence too extraordinary to release? What if grainy images of structured surfaces or inexplicable energy signatures were already locked in encrypted servers, discussed in quiet rooms where decisions were made about what humanity was ready or not ready to know? The silence fed speculation. Scientists pleaded for transparency. Governments gave none. This wasn't the first time secrecy had surrounded the skies. For decades, militaries have monitored unidentified objects in Earth's atmosphere, often withholding details until decades later. Now the same pattern seemed to be repeating on a cosmic scale. The difference was that Atlas and Swan R2 weren't fleeting radar blips or questionable sightings. They were massive visible objects hanging in the heavens for anyone to see. That visibility made total secrecy impossible. Yet it also gave governments more reason to control the narrative carefully. If the world collectively decided these objects were artificial, panic could ripple across societies, stock markets could crash, religions could fracture or surge, political systems could be destabilized overnight. To many in power, such risks outweighed the public's right to know. Better to control the story, frame it as science, and hope the nomans faded with time. But secrecy has a cost. The more governments tried to manage information, the more suspicion grew. Independent astronomers, frustrated by missing data, turned to social media to air grievances. Leaks began to surface. Anonymous claims from supposed insiders about hidden findings, whispers about classified imagery, even mentions of non-natural signatures. None could be confirmed, but each added fuel to the fire. Soon, public discourse split in two. On one side, officials and mainstream scientists insisted Atlas and Swan R2 were unusual but natural comets. On the other, a swelling chorus of voices claimed governments were hiding the truth. The divide wasn't just about the comets anymore. It was about trust, secrecy, and whether humanity was being prepared for something far bigger than anyone had admitted. There were also hints of competition. Reports suggested that China and Russia had independently tasked their military satellites to track Swan R2's outbursts, possibly searching for electromagnetic emissions. If any were found, they would represent the most explosive discovery in history, but also a tightly guarded national secret. In a world where advanced technology equals power, the first nation to capture definitive evidence of extraterrestrial machinery would hold unimaginable leverage. That possibility ensured that, even if such evidence existed, it might never be shared. Instead, it would be classified, studied, and perhaps weaponized, leaving the rest of humanity in ignorance. For ordinary people, this shadow play of governments and militaries remained invisible, glimpsed only through small cracks, delayed announcements, suspicious wording, unexplained data gaps. But the sense of being watched and of something being withheld grew unavoidable. It wasn't just the comets that seemed to be performing a dance. The institutions meant to inform and protect us were dancing too, stepping carefully, avoiding truths they weren't ready to reveal. And in that silence, speculation became louder than fact. Were Atlas and Swan R2 simply wanderers from the void, or were they something far more? The answer might already sit in classified vaults, known to a few but hidden from the many. And if so, then humanity's first contact with interstellar visitors was not just a scientific mystery, it was a political one, a secret guarded by those who had decided the world wasn't ready to hear it. In the end, the governments and militaries of Earth became watchers not only of the skies but of each other. Each nation scanned the comets, wary not just of what they might be, but of what rival powers might discover first. And while the public marveled at glowing tails and eerie green light, decisions were being made behind closed doors that could shape humanity's future. Would the truth ever be shared, or would it remain buried under layers of classification, another cosmic secret lost to secrecy and fear? As Atlas and Swan R2 continued their journeys, that question loomed larger than the comets themselves. While scientists worked cautiously and governments moved in silence, the public experienced Atlas and Swan R2 in the loudest, rawest way possible, through the global megaphone of media. What began as small notes on astronomy blogs quickly erupted into a storm that spread across every platform imaginable. From mainstream news outlets to conspiracy forums and viral TikTok videos, the spectacle of two interstellar objects arriving simultaneously was irresistible, and it didn't take long for it to dominate headlines. What made it so powerful was not just the science but the mystery, the sense that something enormous was unfolding above us, and no one could quite explain what it meant. Traditional media leaned into awe first. Newspapers and television channels released dramatic images of Swan R2's blazing tail and Atlas's eerie green glow. They used phrases like cosmic spectacle, rare double event, and a once-in-a-lifetime show. Anchors smiled as they compared the comets to fireworks across the night sky, encouraging viewers to step outside and look up. But even in those early reports, there was an undercurrent of unease. Every article included phrases like scientists baffled and defying expectations. The very language that was meant to inspire wonder also seeded doubt, hinting at the possibility that what we were seeing wasn't entirely understood. And in a world already hungry for mystery, that small gap in certainty became an open doorway to speculation. Social media, with its speed and lack of filters, took the story further. Hashtags exploded. Green Atlas, Swan R2, twin visitors. Millions of users posted grainy photos and shaky videos of the comets. Some real, others fabricated, many impossible to verify. Memes spread almost instantly. Atlas depicted as an alien scout, Swan R2 as a burning sword streaking toward Earth. Conspiracy theories that would normally take years to brew reached virality in hours. Threads claimed the objects were not comets at all, but probes. Others declared they were omens tied to prophecies, aligning ancient texts with modern astronomy to prove the universe was sending us a message. Whether believable or not, these stories traveled faster than any press release, embedding themselves in the collective imagination before official voices could catch up. The media storm wasn't just about speculation, it was about fear. As soon as whispers spread that Swan R2's orbit might bring it uncomfortably close to Earth, panic surged. News outlets began running graphics showing possible paths, some exaggerated to appear more dramatic. Talk shows invited experts to debate whether humanity could survive a comet strike. Footage of past asteroid documentaries resurfaced, paired with ominous music and bold captions like, "Could this be the one?" For people scrolling their feeds late at night, the message was clear. Even if scientists insisted the risk was low, the possibility was there, and fear always spreads faster than reassurance. Religious leaders quickly joined the conversation, each interpreting the comets through the lens of their faith. Some Christian pastors cited revelations, linking the glowing green of Atlas to the pale horse of death. Others described Swan R2 as the great star blazing like a torch foretold to fall from heaven. Islamic scholars reference passages about celestial signs, signaling great change, while Hindu thinkers tied the arrivals to cycles of cosmic destruction and renewal. Even those outside organized religion felt the pull of prophecy. People who had never looked up scripture before now searched ancient texts online, seeking patterns, signs, answers. The media amplified it all, giving airtime to preachers and mystics who spoke with absolute conviction. Whether they inspired comfort or dread, they gave people a sense of narrative in a moment when science seemed hesitant to provide one. Meanwhile, skeptics tried to keep the conversation grounded. Astronomers appeared on late-night news shows to explain sublimation, outgassing, and orbital mechanics in calm voices. They showed charts and equations, trying to reassure the public that everything could be explained with natural processes. But here was the problem. Those explanations sounded too dry, too safe, compared to the spectacle of the unknown. When one scientist said there's nothing to worry about, while Swan R2 erupted into yet another unexpected flare, it didn't calm fears, it amplified suspicions. People began asking, why should we trust them, if even they admit they're baffled? The cautious language of science, meant to avoid overstating conclusions, was interpreted as evasiveness, and in the echo chamber of the internet, that perceived evasiveness became fuel for claims of cover-ups. The media storm escalated further when leaks began to trickle out. Anonymous posts from supposed insiders hinted at classified data from Mars orbiters that revealed anomalies too strange to publish. Fringe channels claimed governments already knew Swan R2 was artificial but were hiding it to avoid mass panic. A viral video alleged that a whistleblower had proof of structured signals coming from Atlas, though no verifiable data was ever produced. Most of these claims were impossible to substantiate, yet they spread faster than fact checks ever could. The very act of government staying silent or cautious fed the belief that something was being hidden. By the time officials denied the rumors, millions had already accepted them as truth. Public reaction fractured into distinct camps. One camp embraced awe, treating the comets as a unifying spectacle, something to celebrate in a world too often divided. Families gathered in backyards to watch the skies, turning observation into ritual. Another camp surrendered to fear, convinced that impact or invasion was imminent. Survivalist forums buzzed with activity, advising people to stockpile supplies, dig bunkers, and prepare for the worst. A third camp fell deep into speculation, connecting dots between comets, ancient myths, UFO sightings, and global politics, convinced that the universe was revealing a pattern too big to ignore. Each camp fed its own media ecosystem, reinforcing its worldview and dismissing the others. Through it all, journalists wrestled with responsibility. Should they downplay the fears and risk being accused of lying, or should they amplify them and risk spreading panic? Ratings pushed toward the latter. Stories about alien probes or impending doom drew more viewers than sober explanations of cometary physics. Producers leaned into the drama, often framing experts against conspiracy theorists for debate segments that resembled theater more than science. The result was predictable. The spectacle grew, the mystery deepened, and the truth slipped further away. Yet beneath the noise, something profound happened. For the first time in decades, people all around the world were looking up together. Cities dimmed lights so residents could see the comets. Schools organized nighttime viewings, teaching children about the cosmos. Conversations that normally revolved around politics or celebrity gossip shifted to questions of life, the universe, and humanity's place in it. Even if confusion and fear drove the headlines, the comets rekindled something ancient in us. The same wonder our ancestors felt when they looked at Halley's Comet, or when a bright supernova burst into view. The storm of media, for all its chaos, had reminded us of the vastness of existence. But wonder is fragile, and as the days passed, the media storm grew darker. Every flare from Swan R2, every unexplained deviation in trajectory, every delay in official updates became breaking news. Panels speculated on whether governments could be preparing for contact. Rumors tied the timing of the comets to geopolitical tensions, suggesting the skies were a backdrop for secret human plans rather than cosmic accidents. People began to ask not just what Atlas and Swan R2 were, but what our leaders were hiding. And in that space between spectacle and secrecy, between awe and fear, the public's imagination spun the wildest stories of all. The truth was still elusive, hidden behind glowing tails and green light. But one thing was undeniable: Atlas and Swan R2 had captured humanity's full attention. They had turned the night sky into a stage, and every news cycle, every viral post, every whispered rumor was part of the performance. The world wasn't just watching the comets. It was watching itself, its fears, its hopes, its hunger for meaning, reflected in two mysterious visitors racing across the heavens. As the public drowned in speculation and the media storm reached its peak, scientists found themselves caught between wonder and frustration. On the one hand, 3IATLAS and Swan R2 presented the most extraordinary opportunity in modern astronomy, two interstellar visitors arriving simultaneously, each displaying bizarre behaviors that defied expectation. On the other hand, the very uniqueness of the event made it nearly impossible to interpret cleanly. Every new observation seemed to contradict the last, producing datasets that raised more questions than they answered. It was as if the cosmos were dangling clues in front of us, only to pull them away the moment we thought we had them figured out. The first breakthroughs came from spectroscopy. Astronomers had managed to capture detailed spectra of Atlas's eerie green glow during a brief window before the comet slipped too close to the sun's glare. The results were shocking. While comets often display greenish hues due to diatomic carbon and cyanogen gases fluorescing under solar radiation, Atlas's glow was far stronger than predicted. More disturbingly, its spectrum contained unusually high amounts of nickel and other metals, elements typically present in comets but at far lower concentration. Some researchers cautiously suggested that Atlas's chemical makeup pointed to an origin unlike any object previously seen, perhaps from a stellar system with entirely different planetary formation conditions. Others, however, privately admitted that the metallic signatures were so unusual they almost looked artificial, like alloys rather than naturally occurring minerals. Swan R2 was no less confusing. Its sudden outbursts, initially explained as jets of sublimating ice, were later revealed to have an oddly regular rhythm. Astronomers tracking its light curve noticed spikes occurring in near-predictable intervals, as though the comet were pulsing. Statistical analysis showed the pulses were unlikely to be random. The immediate explanation was rotational instability, a tumbling nucleus exposing jets in cycles. But even that didn't quite fit, because the pulses sometimes occurred with uncanny precision, separated by identical gaps of time. Some scientists whispered about the possibility of modulation, a term more commonly used in the context of signals than natural phenomena. Publicly, they stayed cautious, describing the comet as volatile and poorly understood. But in labs and conferences, the word unnatural was being spoken more often than anyone wanted to admit. Then came the orbital data. While Atlas's path more or less matched expectations, Swan R2 continued to defy prediction. Its trajectory displayed deviations too consistent to be dismissed as random outgassing. NASA and ESA released papers attributing the shifts to non-gravitational forces, a technical way of acknowledging anomalies without speculating further. Yet private discussions painted a different picture. Some orbital analysts admitted the deviations looked deliberate, as if Swan R2 were gently correcting its own path. For anyone who remembered the debates about Oumuamua in 2017, this was déjà vu on a grander scale. Back then, Avi Loeb had suggested that the strange acceleration of Oumuamua could be explained if it were a thin, light sail-like object pushed by starlight. His claims had been dismissed by most of the scientific community. But now, with Swan R2 showing similar anomalies on an even larger and more dramatic scale, the dismissal didn't come as quickly. Instead, a growing number of scientists quietly admitted that Loeb's ideas no longer seemed so far-fetched. Amid the breakthroughs came contradictions. Observatories in different parts of the world reported conflicting measurements of brightness, tail length, and spectral composition. Some teams claimed to see variations in Atlas's green emission lines, while others reported steady consistency. Swan R2's outbursts looked regular from some telescopes, but appeared chaotic from others. Was this due to differences in instrumentation, atmospheric interference, or something inherent to the objects themselves? The lack of agreement made it difficult to publish definitive findings, and in science, hesitation often breeds suspicion. The public, already primed for secrecy, interpreted the confusion as deliberate obfuscation rather than the messy reality of frontier research. Mars orbiters added another layer of complication. The Trace Gas Orbiter and Mars Reconnaissance Orbiter both captured data during the comet's closest approaches, offering perspectives Earth could not. Yet the information came back slowly, and much of it was heavily filtered through space agencies before being released. What little was shared added fuel to the fire. Early reports hinted at unusual emissions in the ultraviolet range from Atlas, emissions inconsistent with typical cometary chemistry. Another hinted at structured jets from Swan R2, ejecting material in patterns that seemed too geometric to be random. Officially, these were described as instrumental noise or data artifacts, but among scientists rumors circulated that the anomalies were real, and the only debate was whether to interpret them as exotic natural processes or evidence of something more deliberate. As the data grew more complex, so did the disagreements. Some scientists leaned toward natural explanations, citing the vast diversity of cosmic phenomena and the dangers of jumping to extraordinary conclusions. Others argued that the evidence was stacking too neatly to ignore. At a closed-door conference, one planetary scientist reportedly said, "If we had this data without knowing it was a comet, we'd call it a machine." Such statements never made it into published papers, but they spread through whispers, amplifying the sense that humanity was standing on the edge of a paradigm shift. Meanwhile, attempts to decode Swan R2's rhythmic pulses became a kind of obsession. Teams across the world began analyzing the light curves like signals, applying Fourier transforms, pattern recognition algorithms, and even machine learning techniques to search for hidden information. Most results came up empty, random noise dressed up as meaning. But every once in a while a result would appear that seemed tantalizing, a repeating sequence of intervals, a modulation that resembled binary encoding, nothing definitive, nothing publishable, but just enough to keep the possibility alive. Even if it was all coincidence, the very act of searching for a message in Swan R2's light revealed a deeper truth. Humanity wanted desperately to believe these comets were more than comets. Conflicting data only deepened that desire. Every breakthrough was paired with contradiction, every explanation shadowed by doubt. Atlas's metallic glow was explained as unusual chemistry, but why so extreme? Swan R2's outbursts were chalked up to instability, but why so rhythmic? Orbital deviations were called outgassing, but why so consistent? Scientists were left in an impossible position, caught between the need to uphold rigor and the pull of the extraordinary, and in that tension, trust in official explanations began to erode. For the public, the contradictions weren't evidence of scientific caution, they were evidence of cover-up. The irony was that science was moving faster than ever. Telescopes worldwide were gathering terabytes of data. Spacecraft were relaying unique observations. Teams worked around the clock, racing to interpret findings before the comets passed back into the void. Breakthroughs were happening daily, but so were contradictions. The truth wasn't hidden. It was tangled, messy, and incomplete. But in a world primed for sensationalism, we don't know yet, wasn't good enough. People wanted answers, and when science couldn't provide them, speculation rushed in to fill the void. By the time Atlas and Swan R2 reached their closest approaches, the scientific community was divided like never before. Some declared the objects unprecedented but natural. Others whispered that they might be artificial, and still others admitted they didn't know at all. The breakthroughs were undeniable. New chemistry, new orbital behavior, new patterns in cometary outbursts. But the contradictions made it impossible to settle on one narrative, and so the mystery only deepened, leaving humanity with the unsettling sense that the truth was out there, flickering between the lines of conflicting data, just beyond our grasp. Every great story, whether written by human hands or unfolding in the cosmos itself, reaches a moment where the tension can no longer stretch without breaking. With 3IATLAS and Swan R2, that moment arrived quietly at first, almost unnoticeably, before erupting into something the world could not ignore. Up until this point, the comets had been treated as curiosities, mysteries for scientists, and symbols for those hungry for deeper meaning. But in the weeks following their closest approaches, the situation shifted. Something happened, subtle in data, dramatic in perception, that turned a fascinating anomaly into a global obsession. This was the turning point, the moment the narrative hardened from speculation into a story that demanded answers. It began with the light. Astronomers had been tracking both objects obsessively, monitoring their brightness curves, tail development, and emission spectra. For Atlas, the eerie green glow that had captivated so many was expected to fade as the comet receded from the sun. Instead, something stranger occurred. The glow intensified even as the comet moved farther away. It should have dimmed with distance, but Atlas appeared to be feeding on a source of energy that no one could identify. Its brightness wavered in erratic pulses, irregular at first, then gradually tightening into something disturbingly rhythmic. People who had dismissed earlier claims of signals suddenly found themselves staring at graphs that looked less like noise and more like patterns. Swan R2's transformation was even more dramatic. Having erupted with unpredictable outbursts for months, the comet suddenly stabilized. Its tail, once chaotic and sprawling, began to narrow, becoming sleek and sharply defined, like a blade stretching across the sky. Photographers captured images that went viral instantly, a single luminous streak, bright enough to be seen even from city skylines, hovering in the heavens like an omen. Scientists scrambled to explain it as a shift in outgassing behavior, but ordinary people didn't care about the technicalities. To them, the sight of a comet suddenly sharpening its appearance carried symbolic weight, as though the object had changed from a natural wanderer into something deliberate. Then came the data from amateur astronomers. Unlike space agencies which filtered their releases, backyard observers uploaded raw footage, spectrographs, and brightness curves to online forums. One video in particular ignited the frenzy. A time-lapse of Swan R2 taken over 4 hours, showing subtle fluctuations in brightness that repeated in exact intervals. The uploader overlaid a metronome sound, each tick aligning perfectly with the light pulses. The effect was chilling. Within hours, the clip had millions of views. Within days, it was spliced into conspiracy videos claiming Swan R2 was broadcasting. Whether the science supported it or not didn't matter anymore. The perception had been locked in. Governments could no longer dismiss the public's questions as harmless curiosity. Emergency sessions were convened behind closed doors, and intelligence agencies quietly reached out to astronomers. Reports began to circulate of observatories receiving direct requests not to publish certain findings until reviewed. Predictably, the leaks followed. An anonymous whistleblower released documents suggesting that spectral data from Atlas had revealed compounds never before seen in natural comets. The language was cautious, hedging in technical jargon, but the implication was clear. Something about Atlas defied classification. Official denials only fueled the fire, convincing the public that authorities were hiding something monumental. This was when the narrative truly turned. Up until now, the question had been, what are these things? But now it evolved into something sharper. What aren't we being told? That shift, subtle but critical, transformed the discussion. It was no longer just about scientific discovery, it was about secrecy, control, and trust. And once the idea of a cover-up took hold, no amount of explanation could undo it. Meanwhile, subtle but uncanny coincidences added fuel to the fire. Ancient texts describing green stars and sky swords were dug up by opportunistic historians, linked accurately or not to the visual appearance of Atlas and Swan R2. The Mayan codices, medieval chronicles, even Sumerian myths were reinterpreted as prophecies. Religious groups declared the comets harbingers of change, some proclaiming doom, others promising salvation. For scientists, it was maddening to see centuries-old myths suddenly take precedence over peer-reviewed data. But for the public, the alignment was irresistible. Two bizarre cosmic objects appearing together, coinciding with ancient warnings. It was too perfect to ignore. The true turning point, though, came not from data or mythology, but from an accident. In Chile, one of the world's most advanced observatories suffered a sudden blackout during a key observation window of Atlas. The cause, officials explained, was a technical failure in the power grid, but leaked logs revealed something stranger. Moments before the blackout, instruments recorded a massive spike in electromagnetic interference, strong enough to fry sensors. Engineers insisted it was a coincidence. Conspiracy theorists declared it proof that Atlas had emitted some kind of pulse that disabled equipment. Overnight, the story shifted from weird comets to hostile signals. Whether real or imagined, the idea that these objects could actively affect earthly technology was a psychological breaking point. The reaction was immediate. Stock markets dipped on rumors of space threats. Military leaders were questioned in parliaments and congresses. Social media filled with claims of UFO disclosure, with Atlas and Swan R2 now labeled artificial probes. For many, this was the moment where the possibility of alien contact stopped being fringe and started to feel mainstream. Scientists tried to hold the line, but every cautious explanation sounded like evasion. The world no longer wanted probabilities or models. It wanted answers, and it wanted them now. But here's the most chilling part. Even as panic and excitement spread, the comets themselves seemed to respond. Atlas's green glow shifted from random pulses to a steady beat, like a drum sinking to human attention. Swan R2's tail sharpened further, brightening in flashes visible even to the naked eye. Whether coincidence or something more, the timing was impossible to ignore. The more we looked, the more they seemed to perform, as if in some uncanny way they were aware of us. By the end of that week, the narrative was locked. This was no longer about comets behaving strangely. It was about visitors making themselves known. The scientific community was split, governments were scrambling, and ordinary people were looking up at the night sky with a mixture of awe and dread. Humanity had crossed an invisible threshold, not because definitive proof had been found, but because perception itself had changed. Once that change takes root, there is no going back. That was the turning point. The moment when 3IATLAS and Swan R2 stopped being celestial curiosities and became something more: messengers, threats, omens, or signals depending on who you asked. From this point forward, the story was no longer about observation. It was about confrontation, interpretation, and preparation. The world had been watching the comets. Now it felt like the comets were watching back. And in that realization, humanity's sense of place in the universe shifted forever. The story of 3IATLAS and Swan R2 is not just about two strange objects cutting across the solar system. It's about how humanity reacts when confronted with the unknown. From the very beginning, these interstellar wanderers carried with them a sense of unease. Their simultaneous arrival seemed improbable. Their behavior defied expectations, and their appearances were dramatic enough to capture the public's imagination in a way few astronomical events ever have. What started as distant curiosities quickly transformed into cultural flashpoints, igniting debates about science, secrecy, prophecy, and even the possibility that we are not alone. And in that transformation we caught a glimpse of ourselves, our hopes, our fears, and our unrelenting hunger for meaning. If there is one lesson in this story, it is that the universe has a way of humbling us. For centuries, we told ourselves that the sky above was predictable, a clockwork machine we could understand with enough equations and telescopes. But Atlas and Swan R2 reminded us that the cosmos still holds surprises that can shake our confidence. They were not content to behave like ordinary comets. One glowed unnaturally, pulsing as though it carried a secret heartbeat. The other sharpened and steadied its behavior so strange it seemed almost purposeful. Whether these were natural processes or something far more extraordinary, they left us with more questions than answers. And maybe that's the point. The mystery of these objects revealed how fragile certainty really is. Scientists struggled to reconcile conflicting data, governments hesitated to share information, and ordinary people filled the gaps with myths and theories. Some saw omens of doom, others saw messages of hope, and still others saw the possibility of a cosmic encounter. But no matter where you stood, one fact became undeniable. The comets had forced the entire planet to look up together, if only for a moment. There is a kind of beauty in that. In an age defined by division and distraction, two glowing messengers from the deep void managed to command our collective attention. They reminded us of our smallness, but also of our potential to wonder, to imagine, to prepare for futures beyond the narrow horizons we often set for ourselves. Maybe Atlas and Swan R2 were nothing more than icy relics of other stars, fragments of ancient systems wandering endlessly until fate brought them here. Or maybe, just maybe, they were something more, signs that the universe is not silent, that we are part of a larger story we've only just begun to read. As they faded back into the darkness, slipping beyond the range of our instruments, one truth lingered: we do not know. And that unknowing, unsettling as it may be, is also the spark that drives us forward. It pushes us to build better telescopes, to ask bolder questions, and to prepare ourselves for the possibility that the next visitor might not be content to simply pass by. The cosmos has spoken, if only in whispers. The real question now is, are we ready to listen?